Hello to all, good morning. Sorry to keep you waiting, but we had some technical issues. Today we have with us Dr. Paraskevas Nikolaou. He's now a lecturer at the Cyprus University of Technology in the Department of Civil Engineering and Geoinformatics. Dr. Nikolaou completed his undergraduate studies at the School of Rural and Surveying Engineering at Aristotle University of Thessaloniki. And then he continued his master's at the University of Cyprus, specializing in construction and transport infrastructure management. Since 2020, he was awarded a Ph.D. in civil engineering from the same university, with his research titled Regional Spatio-Temporal Explanatory Modeling of Macroscopic Transportation Information for Supporting Decision-Making Processes. This provided innovative insights into transportation modeling and decision support systems. From May 2022 to January 2024, Dr. Nikolaou conducted postdoctoral research at Aristotle University, focusing on the spatio-temporal interplay between urban development and transportation systems. Thanks, Paris, for being with us. So we'll continue with the Dr. Nikolaou presentation. If you have any questions, we have a session at the end of the presentation, and also a follow-up discussion will follow up to identify any potential synergies between Eratosthenes staff and Dr. Nikolaou. Thanks, Paris.
Thank you, Maria. You want me to share the screen here?
Yeah.
Okay. Πρέπει λογικά να με αφήσει ποιος κάνει το meeting, να μην initiate το meeting. Να πρέπει να μου δώσει access για το... One participant can share at a time. Οπότε, σε λεπτό... εντάξει, οκ. Ναι. Λοιπόν, πάμε αυτό. Οκ. So, can you all see my screen? For those who are actually online,
Yes, we can see that.
Okay, perfect. Okay, I would like to thank you, Marie, for the introductory of myself. And actually, my name is Paris Nikolaou, as Mario said. I'm a lecturer, transport engineer, and the head of transportation engineering lab in the Department of Civil Engineering and Geomatics in Cyprus University of Technology. So today's actually presentation will be on transportation systems, and I will provide you an introductory and definition of transportation systems, the evolution of transportation systems over the time, focusing from the 19th century and forward, the components, dimensions, and importance of transportation systems, the different types that we have in transportation systems, and also we actually focus on specific types, which will be public, intelligent, resilient, and space transportation systems. And at the end of the presentation, I will provide you some conclusions overall of the presentation. So what the transportation system is? Transportation system is a combination of elements which are considered as modes, commuters, either goods or either passengers, and the infrastructure. And there are interactions which actually produce the demand for travel within the given area and the supply of transportation services to satisfy this demand. In order to further explain the transportation system, we have an example of the urban public transit system in a metropolitan city like such as London, for example. So the elements of the transportation system are the commuters, the passengers of this specific transportation system, which are residents, students, tourists, and workers that actually desire to make a movement based on the different purposes using the existing infrastructure and existing alternative modes. So the interaction between the demand for commuting and the supply of providing the services of commute, it's actually the entire system combines the transportation system. So transportation system provides the necessary connectivity that enhances the interaction between people and also the goods. That facilitates the movement of people and the spreading ideas. Advances in transportation technology actually have made a revolution in the civilization as we know it. And since ancient times, cities actually have developed close to physical and available terrains in order to make commuting easier for them, especially close to rivers or coastlines, etc. So what is the evolution of the transportation system? Actually, we'll focus from the 19th century and forward, where in the 19th century you have the Industrial Revolution, steam engine technology, where you have transportations over canals, transportation of goods and passengers. Then we have the construction of railways in the 1830. And in the 1930, we have the Great Depression, where actually the US stock was dropped, and we had the decrease of oil and petroleum, where the automobiles actually were not able to move. So then we have the further road infrastructure development, the born of the automobile with a modern industrial development, the development of air infrastructure, and the autonomous vehicles. So following up the evolution of transportation system, we came up to the question, so what is the next step? As far as I know, in Dubai, I think they will implement a new transportation mode, which will be the mode of commuting passengers through drones. So the dimensions of transportation, we have different dimensions of transportation, such as historical dimensions, where actually, as we mentioned, civilization actually evolved through the evolution of transportation systems. Economic dimension, of transportation, where we have transport and economic development, which are highly related. Social dimension, where now through the transportation systems, we have access to healthcare, welfare, and cultural events. Political dimension of transportation, it's important to also mention that during the presidency, we have one hot topic, which was the transportation problem in Cyprus. Environmental dimension, where as we know that the European Union has some regulations, some limitations on the emissions through the transportation system, which is also important to notice. The components of the transportation system, as I mentioned in the beginning, we have the modes, the alternative modes that exist in different locations, the infrastructure, the networks, the railway, the road network, etc., and the flows which will combine the movement of people and goods throughout the entire transportation system. The classification of the transportation system, we have different types of transportation system, which combine by land transportation, air transportation, water transportation, and lastly, but also important, is the pipelines, which are also considered as a part of the transportation system of transporting oil, gas, and other materials. So one of the characterizations that I can say for the transportation system is that besides the modes, the different infrastructure, and the kind of the objects that we transport either as people or objects. We have also the scale of the transportation system, which are actually combined by urban, regional, intercity, and international, the transportation of freights and passengers, and also either if we have let's say private ownership of the transportation system, or a public, or even joint between private and public ownership in the transportation system. An example here, I can say that it's a public transportation system in Cyprus, where the operators are actually private ownership, but they are actually follow the framework that the Ministry of Transport has actually made for them. So the importance of the transportation system is that growing transportation, growing demand actually is related with also the growth of the transportation, as many people desire to move. So we are actually in the position to make an evolution of the transportation system in order to fulfill the demand of the existing demand or future estimated demand. The reduction of cost using transportation modes, for example, public transportation, help us in order to be able to reduce our cost in contrast of using our private vehicles. And also the expansion of infrastructure, which also a growing importance of transportation. So what are the physical constraints of transportation systems? Our topography are the main constraints are considered as topography, where we have the terrain. For example, designing different terrains in difficult terrains make the infrastructure of the transportation system more difficult to actually construct it. Hydrology constraints and climate constraints. What are the types of the transportation system? As I mentioned before, we have the public transportation system, the rail transportation system, urban, airway, freight, pipeline, intelligent transportation system, sustainable, resilient, autonomous, and space transportation systems. So as I mentioned, today we'll focus mainly on the public transportation, also the intelligent transportation systems, the resilient, and the space transportation systems. For the public transportation, it's actually the provision of the modes that are considered as either public or joint ownership, which actually are provided to the people in order to make their commute from different locations to different destinations. So why we actually start in the consideration of the public transportation system started from the demand for movement. All right. In order to further actually see this actually the specific system enhanced during the years where we noticed that people moved from the rural areas to the urban areas. Specifically, when the secondary and tertiary sectors were increased, specifically manufacturing and other services in the urban areas, so people moved in order to be able to find the work in the urban areas, and this phenomenon called as urbanization. So from the urbanization, it began the demand for providing to these people the ability and the mode for commuting. So we started to further study public transportation system. So urbanization, just to have a point here, we can see from the table that in 1990, different countries, we can see the different economic sectors, the primary, the secondary, and tertiary sectors that actually had the majority of the three sectors during the 1990 between United States, United Kingdom, the Netherlands, Norway, France, Japan, Germany, and Italy. So also, in order to further notice the urbanization and the growth of the cities, we can see this from the beginning of the 19th century to the 2003, where we have the percentage of people living in urban areas. As we can see, all of the countries here denoted in this table have actually a huge increment of people moving to the urban areas, which actually created the further demand for Iothony.
There is a hibernation.
So, sorry, just a minute.
I'm sort of like
Okay. Let's go. Okay, so can you all see the screen?
Yes.
Okay. So, as I mentioned before, through the years, we can see the urbanization and the growth of the cities where people actually moved from the rural areas to the urban areas. Another example is this table where we can see that from the beginning of the 18th century to 2002, we have the number of cities with a population over 100,000 by continent, where we can see that every continent has an increment on urbanization phenomenon during this age of years. So the important thing is that having people moving from the rural to the urban areas increase the demand for movement, as I mentioned. So the public transportation system began even from the ancient provenance of the boat as a public convenience which actually started from the Greek mythology of Charon, which was the ferryman of the Styx River. So the concept of public transportation began then, even from the mythology, but efficiently began from the 17th century. We have the coaches in London at the beginning of the 17th century. Then we have the sedan chair in Paris in 1670. And also we have the public coach in Paris in the 1662. So the evolution of the public transportation system is another topic that actually was considerable over the years. And we can see from this table for the last 50 years and more, we have the evolution of the public transportation system, where I can focus from since 1990 in Western Europe, USA, Japan, and Singapore. We have the extensive application of intelligent transportation systems. So beginning from the typical public transportation systems as presented before, that public transportation system evolved to semi-rapid, to rapid transit systems, and to the systems that also implemented intelligent transportation systems. So the characteristics of the public transportation system is that we have the system performance, where we count the system performance, we measure the system performance by using service frequency, operating speed, and safety. Have the level of service, which actually characterizes the performance of the public transportation system, the service quality, the price. We have the impacts that actually provides the public transportation system over the surrounding area that it serves, and the cost, which is considered as the investments and the operating cost of the operators of the public transportation system. So how the public transportation system can be considered or is considered different areas. We can see from the left that we have, for example, sparse settlement areas where people actually move and commute by either walking or either by private vehicles. Then as the area increases by size of population, then we have the creation of small cities where we have the addition of arterials and the implementation and construction of public transportation services. Then we move to medium cities where we have the introduction of semi-rapid transit. Semi-rapid transit can be the BRT, the bus rapid transit, and also to the large cities where the people actually, the population densities have actually been increased, and so have the addition of freeways and the rapid transit, which can be considered as the subways. So, taking step by step the evolution of the transportation system in a modern urban area, we start from the small areas where the people commute by walking. Then we have the use of individual private vehicles, then the introduction of vehicles as common carrier services, the introduction of common carrier services, but first by medium-sized vehicles with regular operations, then by bus transit. Then we have the construction of wider roads and streets, which might be in some cases not efficient, but in some other cases is the next step. 3 is the partial separation of modes, introduction of guided transit, construction of grade separate divided roads, provision of fully controlled rapid transit, and the full automation of common carriers like the subways. For further understanding the public transportation system, we'll go actually from the concept of public transportation system planning. So as you can see from this plot, the y-axis, which is actually symbolized as X, is the space of the city, and the x-axis, which is the t, is the time. So the thin arrows represents the demand from moving from one location to another location, the origin and destination, and it shows that the people actually travel to different locations of the city during the time. So the thick line represents the existing public transportation system that commutes from one location, which is a stop, to another location, which is another stop. So the concept here when designing public transportation system is that we need to adapt the existing desire, the existing demand to the supply that we have, or even to expand our supply in order to fulfill the demand. We need an equilibrium between demand and supply. So this is a concept that we actually have during the planning of public transportation systems. The KPIs that we use, the key performance indicators that we use in order to either evaluate the existing transportation system or either to proceed with planning a new public transportation system. Some indicative KPIs are the distance between stops. In most of the cases we use as a distance, actually it's also based on the population densities, but in some cases we use 250 meters to 400 meters, etc. We have the coverage of the areas from the routes. It's important that the routes are actually passing through areas in order to provide the cover. The deviation from main routes, the route's length, the coverage between the routes, the frequency, which is also very important, the number of passengers, the compliance with the scheduled routes. And if I had to actually add another KPI, it will be the information to the people, which proved to be very significant, especially in the case of Cyprus, where people do not have the information of the public transportation system, the routes and the times. So this will be an indicative KPI in order to efficiently evaluate existing public transport. So what are the arguments for supporting public transportation system? Equity. Equity actually is a new term that we use for the last 10 years for the public transportation system. It's actually the provision of access to the people who actually cannot use alternative modes. The congestion, many people actually prefer the public transportation system compared to a private vehicle, for example, in order to, let's say, avoid congestion. But also for the case of Cyprus, this is not an argument because we don't have BRT, the bus rapid transit. So congestion is something that the public transport also faces during peak hours. So land use influence for the public transportation is necessary but not efficient to change land use. Environmental arguments, which actually we all know that the environmental outcome from using public transportation system is efficient compared to using private vehicles. The energy, many more. The other arguments that we also use because we have some, let's say, issues that, for example, accidents, impact on human health, congestion, noise, and global warming, which are costing, have an external cost to the local authorities and to the transport in cities. So it's some factors that we need also to consider when proceeding with the planning of new or either the evaluation of existing public transportation systems. So what are data, actually what data do we need in order to either consider planning or either evaluating existing public transportation systems? Some of the data that are necessary to be used are operational data, which are mainly obtained from the general transit fleet specification, ridership data, land use and socioeconomic data, real-time GPS data, incident reports, also traffic counts, and many other data. But for starting from the point of evaluating the existing public transportation system, these data are efficient for proceeding to provide an efficient also evaluation of the public transportation system. So let's take the example of Limassol. All right, from the left side, you can see the picture, the satellite view picture of Limassol in 1990. And on the right side, we see the picture of the satellite picture from Limassol in 2022. But as you can observe, the resolution is not the same. So of course, there are some differences on the two pictures, but what I actually want to point out is that in the circle, in the red color areas, you can see that we have a different, let's say, density of buildings compared to the two pictures, which is a gap of 30 years. So as you can see from these two different pictures, we can actually be able to estimate the construction model that Limassol is following, which is a spreading city, a sprawl city, which actually is important when designing public transportation systems. Why this is important? Because population densities change, so it's significant to be able on designing new transportation systems, public transportation systems, to be able to fulfill all the demand and to actually predict the population demand and be able to provide this for the people using public transit modes. So as you can see in the next picture, we can see the existing public transportation system, which is operated by buses in Limassol. You can observe that we have too many stops, and also we have a dense public network, which in some times is not efficient. Why is not efficient? Because it increases the route length and also the travel times. Increased travel times actually compared to private vehicles provides disadvantages to the public transportation system. So moving on to the next transportation system, which is the intelligent transportation system. Many of us know the term ITS, which is the solution based on the combination of telecommunications, computer technologies, designed and developed to improve the management, maintenance, monitoring, control, and safety of transport. So ITS includes different tools and services. Between them are the automatic traffic management system, the public transport information services, the travel information system, the fleet management location system, emergency management, electronic payment systems, cooperative vehicular system, and some visual example. As you can see, we have some infrastructure subsystem which either measure traffic counts, or we have the traffic lights, the smart traffic lights for better controlling traffic congestions. We have weather stations that are able to estimate and predict weather conditions that may influence our infrastructure. Have parking management through technologies of, for example, mobile phones and other, let's say, gadgets and technologies that are able to assist the traffic management in the traffic control, and then the traffic management to provide emergency management, transit management. So ITS is essential for either improving on comfort, on providing comfort in the travel time saving by reducing the number of unwanted stops, or by reducing waiting time. For example, we all use Google Maps as let's say a part of ITS, which provides us best routes for minimizing travel time. Road safety, which actually provides controlling speed of vehicles. We have also smart cameras in the signalized intersections, which are also providing efficient measures for road safety. And also ITS provides further improvements in management and environment control. So the next transportation system that I will speak about today, I think it's also under the interest of Eratosthenes, is the resilience of transportation systems. For those who are not familiar with the resilience, is defined as the ability to withstand and maintain a certain level of functionality of performances compared to their reference regular planned level during the impact of disruptive events, and to recover reasonably rapidly afterwards. So a disruption, we will see in the next slides what actually disruptions do we have. So consider that the infrastructure, let's say that the road network has a specific operational level. Then we have the disruption, for example, let's say storm, and let's say we have a failure of a specific segment of the road network. So this disruption has an impact that takes time, and also at this time we need to recover and come back to the operational level that we were initially were. So the resilience is considered as the time from the disruption of the impact of the disruption and up to the recovery in order to come back to the operational level that we were. In order to study resilience, it is important to see all the performances of the transportation system and all the components of the transportation system in order to take them under consideration for studying resilience. These performances are the infrastructural, social, environmental, policy, economic, operational, and technological performances, which, as you can see from this picture, are directly or indirectly connected. So disruptive events are considered either as internally or externally, which may affect the planned regular functionality of performance of the transport modes and their system, and also the specific infrastructure, the safety and security of persons and goods and properties, both internally and at the surrounding communities and the environment. So some external disruptive events are considered as severe weather, climate change, natural disaster, terrorist threat and attacks, cyber attacks, epidemic and pandemic diseases, and also before going to the internal events, for the external disruptive events, we have an example of, let's say, disruptive events from weather, which severe weather, where you can see that inside Europe from the 2000 to 2009, we had a total of 300 disrupted events from severe weather, which of them 153 were considered on their own network, then on the rail, on the sea, on the air, on the inland waterways, and other transport systems. So for the internal disruptive events, we have the failures of components of transport systems, where we have mechanical failures, for example, of railway facilities. We have the industrial actions of the air transport system staff, where we have the strikes and the traffic incident and accidents, which is actually a topic under my research interest right now. So the metrics that we have for measuring the resilience of the transportation system is the performance indicators. As we mentioned, also for the public transportation system, we have some KPIs that we are actually used over the time in order to see how resilient the system is. The recovery time, the purpose here, the objective here is to minimize the recovery time. So it's important to notice this specific factor. The network characteristics, the type of network and the extent of preparedness, and the transport modeling. So as you can see from this figure, it's important from the event in order to recover and come back to the operational level, to the system function from the x-axis, from the y-axis, sorry. It's important to instead prevent the continuous line and go to the dashed line, where we need to make an influence of ex-ante mitigation, so to predict the event before happening, and also the influence of the ex-post adaptation, so in order to be able to have a strategy in order to be able to face the disruption and to come back to the operational level that we were. So the last transportation system that I will present today is the space transportation system. Actually, also, I think, under the interest of Eratosthenes. What is the space transportation system? Actually, space transportation refers to the systems, technologies, and methods used to transport payloads, for example, satellites, cargoes, or humans, from the Earth's surface into space, within space, or back to Earth. So these systems are essential for supporting a range of space applications, for example, satellite deployment for communication, navigation, Earth observation, human spaceflight, space cargo missions, deep space exploration. For a connection between the resilient transportation system and the space transportation system, I will say that space transportation system provides two significant informations: weather monitoring and disaster warning and management, which are essential for predicting events, so to be able to face and make the infrastructure, the modes, resilient in order to avoid any delays in recovery time. So in conclusion of today's presentation is that transportation systems are backbone of economic growth, urbanization, and global connectivity. Evolution from canals to autonomous vehicles highlights technological and societal progress. Public and intelligent transportation system address equity, congestion, sustainability challenges. Resilience and adaptability are critical in the face of climate change and disruptive events, and future innovations such as space and transportation, AI-driven systems will redefine mobility. And as I mentioned, efficient transportation isn't just about movement, it's about enabling progress, equity, and sustainable future. Thank you very much. I think now we'll be able to accept any questions.
Any questions from the audience?
question regarding the, you showed somewhere robustness.
Μισό λεπτό για να το κάνω λίγο.
Somewhere you had a graph with robustness. For an ITS system, you had something with robustness. How do you measure robustness, or how do you define robustness in your case? Yes, this one.
Okay, actually, it's we determine the extent.
What?
How much time it takes to recover from the disruption?
Exactly. What we count now, it depends, of course, of the disruptive event, okay, and where it happens. The research actually topic that I study now is the accidents, which are considered as internal disruptive events in the highways. So having an accident, all right, what is the recovery time where the operational function, the function of the highways will come back to their initial position? So robustness there is counted as the duration of the duration of the recovery time, which is combined by different other times. Dissipation time, response time of the emergency services, report time, and other. Yes.
Anything else from the audience? I have one question.
Yes.
Maybe it will create some more ideas to the audience as well. Because I saw in your last section of the presentation, you presented about the interaction of, let's say, satellite systems with the ground sensors or ground data, let's say, but the part on the space and part on the, to your experience, how data from space are utilized in your, let's say, expertise?
What we actually need for
Sorry, I was on mute. So what we need is actually to have predictions or weather monitoring. So if we have these measurements from satellites, we will be able to predict, or we'll be able to actually see the vulnerability of different infrastructures in different areas that will be possibly be affected from a predicted, let's say, weather condition, weather event, as a disruptive event, and then be able to see after the vulnerability, what is the resilience of this specific infrastructure in case that this, let's say, event happens.
And apart from weather data, the part of the early warning for disaster, I mean, you have the meteorological, let's say, impact on infrastructure. What about impact from other sources like earthquakes, landslides?
Of course. The weather monitoring, it was an example, but of course, every disruption that it was, as I mentioned, considered as external and internal disruption, even terrorist attack, which I don't know if something that can be monitored from satellite observation. But yes, I mean, every disruptive event is important because resilience is essential these days, and it's important to actually have observations from every kind of monitoring that the satellite provides, and also a prediction that will be used in order to, let's say, estimate the vulnerability and the recovery time, and thus the resilience of the infrastructure. Yes.
Any other question?
There was a comment at the beginning.
Okay. I mean, if there is no other question, I would like to thank Paris for his presence here. And of course, we can continue the discussion here at Eratosthenes with the colleagues that are in the room, and we'll see any ways we can collaborate. So thank you all for being with us today. And thanks to Paris for his presence as well and his interesting presentation.
Thank you for inviting me, all the team here, and the hospitality here. Thank you all.